Hey, good evening, everyone. Welcome back after 2 weeks. Okay, never see you for half a month. Okay, welcome to the physics lesson on DC circuits. Okay, so we have finished current of electricity the last time, and we are going to use that knowledge, okay, to form simple, useful circuit. Okay, and that will be the fundamental of creating circuits for your usage in the future. Okay, so today is 17th of May, Tuesday. My name is Mr. Chu. Okay, let's begin. Okay, so this one I will not spend much time. I've gone through this many times. Okay, so we are now at the purpose part. Okay, we have finished static electricity. We have gone through current of electricity. So the topic of current of electricity is just the fundamental. It's just introducing the concept of current, potential difference, and resistance. And then we are going to use all this knowledge into this topic that we're going to do today called DC circuits. Okay, among these 7 topics, these purple topics, I will find this topic will be the most fun because you get to actually create circuit itself. Okay, so we'll be doing DC circuits from today. After this, then we talk about practical electricity. Okay, so the word practical sounds like more useful than DC circuits, right? But practical electricity is more about measuring power, how much power you need, and then and all the safety electricity measures that you require. Okay, so once we finish practical electricity, we will be done with the electricity part. Then we go into the magnetism, then we combine them together. Okay, so this is the whole overview of where we are today. Okay, so before I continue, can I have a show of reaction? How many of you have learned DC circuit? If yes, just give me a yes reaction. If you have not learned, give me a no reaction. This will make me determine how fast to go. Okay, if you have learned DC circuits in school, give me a yes reaction. If you have not learned, give me a no reaction. Okay, so far, Ryan and Yuting has learned, Oscar has learned. Hao Rui, Bei Kwan, and Xiao Xing, have you learned this topic? Bei Kwan and Hao Rui, are both of you there? Hao Rui, how about you? Okay, so I can go very fast because all of you have learned. Wow, 2 weeks make you all learn so fast. Okay, let's continue. Okay, so all of you take a look at this. This is the syllabus. Okay, so mainly we are going to talk about the differences, the current and PD in circuits, and how are they different in series and parallel. Okay, you're going to learn about these new things called the potential divider circuit as well as thermistor and light dependent resistor. Okay, so these are the 4 subtopics for this topic. Okay, Bei Kwan is learning. Okay, how about Howry? How about you? You haven't given me a reaction yet. Okay, so for this topic, the most important thing is the first 2 parts. Okay, because you are doing pure physics, you are learning the next 2 parts. Okay, the combined physics student don't really learn the last 2 much. Okay, so let me just go through very quickly. What are the 9 things that you need to know? Okay, first of all, you need to know how to draw circuit diagram with power sources. Okay, so basically power sources is just battery. Okay, battery. This is how a battery look like. Okay, switches looks like this. Okay, switches look like this. Lamp. Okay, all of you must learn all these symbols. Lamp looks like this. Okay, resistor, there's 2 types. One type looks like this. The other type, it looks like this. Okay, the first one is a fixed resistor. The second one is a variable resistor. Okay, so there's a lot of things down here. Ammeter is a circle with an A and so on. Okay, I'll go through this in a while later. Okay, so you all will need to know how to draw the symbol for every single thing. For the first timer, it may be very overwhelming. But why you are learning this is because this is a fast way of drawing, and everybody in the world learn all this method. Okay, so when we standardize, okay, regardless of what language you are using, when you draw the circuit diagram, you'll be able to communicate what you want to someone else in another part of the world. Okay, so that's the reason why you need to learn symbol, the diagram, or the symbol, so that you can communicate with each other. Okay, it's like a common language. Okay, so next thing. Okay, so the first part I'll go through later. There'll be a lot of examples. Okay, let me talk about B. State that current at every point in the series circuit the same apply the. Okay. So what does part B means? So I just do a very simple circuit. So I have the battery. I go through one bulb. And I go through one resistor. And I come back. Okay, so are you familiar with this? The new thing is the resistor. Okay, you have not learned resistor in primary school, so in secondary school you learn the resistor. The rest, all of you should be familiar. Okay, so for conventional current, okay, it moves from plus to minus. So this is your conventional current itself direction. It moves from plus to minus. Okay, so at every single point, so these two are arranged in series. So if you are a conventional current, there's only one path for you to go, from the plus all the way to the minus. There's no alternate path. So this is called a series circuit. Your current has only one path to go, and when it has only one path to go, the current is the same. So what do I mean by that? If I were to put a ammeter here, I put another ammeter here, I put another ammeter here, and another ammeter here. All these 4 ammeter will show you a same result. So if the first ammeter show you 2 ampere, the second one will show you 2 ampere, the third one will show you 2 ampere, and the fourth one will show you 2 ampere. Is that clear? Okay, if you understand this concept, give me a clap reaction. Thank you, Yiting. How about the rest of you? If you understand this concept, give me a clap reaction. Thank you, Bei Kuan, Oscar, Ryan Hao-Ray, and Qiao Xing. Do you understand this? Okay, next thing I want to ask you. Since they all have the same ampere, regardless you put 1, 2, or 4 ammeter there, let me ask you a question. What do you think is the resistance of the ammeter? Okay, what is the resistance of the ammeter? Do you think it's very, very low or very, very high? So can you type it out in the chat? Is it as close to 0 or close to infinity? So choose one of the 2 answers. Okay, Yiting, correct. How about the rest of you? Can you tell me what is the resistance of the ammeter? Is it close to 0 or close to infinity? Okay, so far only Yiting give me the correct answer. The rest of you? If you are unsure, type unsure in the chat. Bei Kuan, well done. Hao-Ray, well done. How about the other 3 of you? Okay, let me just continue to explain. Let's not wait. Okay, let me draw the same circuit again. Okay, this is the same circuit, right? Just that I put the bulb at a different location. Okay, for let's say if I have 2 ampere of current, 2 ampere of current moving in the circuit itself, if I were to add in another resistor, okay, if I add in another resistor, so what does a resistor do? Okay, if you learn in lower secondary or even in primary school, you will learn that any additional resistor, the higher the resistance, the lesser the current will flow through it. Do you remember that? Okay, that is what you learned last time. Okay, then what is the new definition of resistance? Okay, the new definition of resistance is V over I. Okay, you remember? Okay, so in the past, the simple way of understanding resistance is the more resistance there is, the less current there will be. Make sense? Okay, so now if I were to add one more resistor there, the current moving through the whole thing will go down. Okay, all of you understand that? So if I were to put an ammeter here, for the ammeter to record the correct current going through, it should not have any resistance, because any additional resistance, the current will drop. Is that clear? So if, for example, in the example on the red color circuit, if I put four ammeter here, if the ammeter all has high resistance, they'll all record a low current, a lower current. Okay, so to measure the actual current of a circuit, your ammeter must have effectively no resistance. Is that clear? If you understand by this thing, give me a thumbs up. Okay, if you understand that ammeter should have no resistance to effectively measure the current, okay, give me a thumbs up. And if you understand why, give me a thumbs up. Xiaoxing and Howie, are you okay? All right. Okay, so this is what we have gone through is the B. Okay, we state that current at any point in the series circuit is the same. Okay, now we talk about the series itself. Okay, let me redraw this in another manner. Okay, is this the same circuit as just now? Same circuit, right? One resistor and one buck. So we are going to talk about the third thing now. Okay, the potential difference in a series circuit. All right. Okay, so what actually happened in a series circuit? Okay, if there's no battery, everything along the circuit will have a potential of 0 volt. Okay, I repeat myself again. If there's no battery, there's nothing in the circuit, it's not running. Okay, everywhere in the circuit, there will be 0 volt. Okay, every potential is 0. Okay, so what actually happened is here. Okay, if there's nothing here, if I were to point, if I were to measure this point, okay, it will be 0 volt. Is that clear? Okay, so what the battery do is to raise this potential difference. Okay, this potential, okay, not the difference, to raise this potential to a bigger number. So for example, if you use a 1.5 volt battery, okay, what the battery do is to raise up this point to 1.5 volt. Is that clear? So a battery helps to increase the potential from 0 to 1.5. All right, so that's what the battery does. And then what does this component does? This component actually let the potential drop to 0. Okay, so what we already ascertained is here, this point is 1.5 volt and the bottom point is 0 volt. Is that clear? So what does this two load do? It will reduce the potential from 1.5 to somewhere in between and then to 0. Is that clear? So, for example, this resistor may drop the potential from 1.5 to 1.0 volt. Okay, so if I were to put a voltmeter, okay, if I were to put a voltmeter and then measure these 2 points, okay, can you see? Okay, don't ignore the arrow. I'm just trying to show you that what a voltmeter do is just compare the difference between the 2 points. That point we call it potential. Compare the difference of the potential, okay, or compare the difference of potential, then it'll give you a result. Okay, so a voltmeter, one point at 1.5, the other point at 1.0. The voltmeter calculate the difference, it'll give you a result. Now in this case, 0.5 volt. Is that clear? Okay, so what a voltmeter does is just comparing the differences between 2 points. Okay, the actual definition will be the voltmeter actually just calculate the differences between two potential. Okay, so the potential at this point is 1.5 volt. The potential at this point is 1.0 volt. This voltmeter measure the difference between these 2 points. Okay, so what the battery does is to increase the potential from 0 to, let's say, 1.5 volt. So if I were to measure, if I were to put a voltmeter here, it measure the difference between the 2 points. The voltmeter here will show you 1.5 volt. Because the point below is 0 volt, the point above is 1.5 volt, the difference is 1.5 volt. And that is what the voltmeter show. Is that clear? Okay, so let me talk about point C. Point C state that the sum of the potential difference in a series circuit. What does this mean? So if I were to draw another voltmeter here across the buck, okay, this buck will show you 1.0 volt of potential difference. Okay, so this voltmeter across the buck will give you a reading of 1.0 volt of potential difference. Okay, this voltmeter will actually give you a reading of 0.5 volt across this resistor. So far, any question for me? Okay, so what does point C means? Because these two are in a series, okay, if I were to add the potential difference of these two, I just need to add them. That's all. I just need to add the potential difference. Okay? Is that clear? So what do I mean by that? If I were to put another voltmeter here and here, this is the sum of these two components. So this voltmeter will show you 1.5 volt. Okay, so this is the sum of these two if they are in series. Okay, if you are clear about this, give me a thumbs up before I ask you a challenging question. Okay, if you are clear about the sum of a potential difference in a series circuit is just adding them together, give me a thumbs up. Okay, Haori, thank you. Bei Kwan, thank you. Yuting, thank you. Ryan, Oscar, and Chelsea, do you understand? Okay, thank you, Oscar. Thank you, Chelsea. Thank you, Ryan. All right. Now my question to you. Okay, let's assume the current flowing through this is still the same as just now, 2 ampere. Okay, so for a voltmeter, can you tell me a resistance of a voltmeter should be close to 0 or close to infinity? Okay, can you type it out in the chat? Thank you, Yite, you're correct. How about the rest of you? Okay, what do you think is the resistance of a voltmeter? Will it be very, very low or very, very high? Okay, only Yuting got the answer correct. The rest of you, can you tell me the resistance of the voltmeter is very low or very high or unsure? Okay, can you think about it? Okay, Ryan, correct. How about the rest of you? Hello, only 2 of you answer me. Okay, let me give you a clue. Without the voltmeter, 2 ampere of current will flow through everywhere. Understand? Without the voltmeter, 2 ampere of current flows through anywhere. So introducing the voltmeter should not change the amount of current flowing through the circuit. Correct? So when the 2 ampere of current reach this junction here, it might make a choice. Does it go to the voltmeter or go through the resistor? Okay, so the voltmeter shouldn't change how the current changes. Okay, so all the 2 ampere should actually go through the resistor. So for that to happen, does your voltmeter need to have a very high resistance or very low resistance? Okay, very good. Bei Kwan correct, Hao Rui correct. Okay, so the correct answer is usually your voltmeter has very high resistance because it shouldn't change the way the circuit works. Okay, the voltmeter, the purpose of a voltmeter is just to measure the difference of the potential between 2 points. That's all. Okay, current shouldn't be flowing. Maybe there's some current, very little. Okay, but most of the current should be as per normal going through the load rather than going to the voltmeter. Okay, so it's opposite to ammeter. Ammeter is in series. The resistance should be as low as possible. Okay, so that your current should be still will remain the same. Likewise, your voltmeter, there should be no current flowing through the voltmeter. So for that to happen, the resistance of a voltmeter should be as high as possible. Is that clear? Okay, so if you learn, if this is the first time you heard about this, give me a thumbs up. Okay, only Hao Rui. The rest you learned this before. Okay, if this is the first time you heard about this, give me a thumbs up. If it's not the first time, give me a yes reaction. Okay, you think I heard this before? Okay, so are you all now very clear about series? Okay, so what potential difference does, okay, is that the battery actually raise the potential difference and then your load actually reduce the potential difference. Okay, so now I'm going to draw another circuit. Okay, the same thing, but now these two items are in parallel. Okay, so the bulb and the resistance, they are now in parallel. Okay, likewise, no change. Okay, likewise, the battery. Okay, there's a plus and minus. Okay, the point before the battery, this point is 0 volt. So what the battery does is to raise the potential from 0 to 1.5 volt. I'm assuming that the rating of the battery is 1.5 volt. Is that clear? The EMF of the battery is 1.5 volt. Okay, so now let me go through part D. Yeah. Okay, same as earlier on. If I have 2 ampere of current coming out from the battery, so when the current reach this junction, okay, now this current has a decision to make. Okay, either go through the bulb or go through the resistor. Okay, so what happened is, okay, let me change this from I1. Okay, so at the junction, some of the current will go to I2, some of the current will go to I3. So for part D, what you need to know is in a parallel circuit, current 1 is equal to current 2 and 3. Does that make sense? So if this is 3 volt, 3 ampere, okay, and then the current that goes through the resistor is 2 ampere, you're only left with 1 ampere, that 1 ampere go through the bulb. Can? Just like there are 6 of you running here, okay, 2% run through the bulb, 4% run through the resistor. Okay, and then at the junction here, all of you unite again, combine together, going back to the battery is still the same, 3 volt. Oh, sorry, not 3 volt, 3 ampere. Is that clear? Okay, so I1 is equal to I2 plus I3. in this example, this is how the current actually is broken up in a parallel circuit. So if you are very clear about this, give me a yes reaction. Thank you, Ryan. Thank you, Pei Guan. Thank you, Yiting. Thank you, Oscar. Thank you, Howrey. Xiaoxing, are you okay? All right. Now, let me just add on a bit more before I talk about the PD. If there are 3 ampere of current coming from the battery, when it reach the junction, how does the current decide who to go to where more? Okay, so which one is higher, I2 or I3? How does the current decide? Okay, I'm using a very layman term to explain. So let's, for example, if the resistance of the bulb is low and the resistance of the bulb is high, okay, if this is low, this is high, this is low. If you are the current, you want to make life easier for yourself. Most of you will go through the low resistance load, okay? And then the high resistance load will have less current because more resistant, harder to go through, so there'll be less current going through. Okay, but in the end, the I2 plus I3 must still add up to become I1. Just that in this example, there'll be less current going through the resistor because it's higher resistance, and then there'll be more current going through the bulb because the resistance is lower. Does that make sense to all of you? Okay, in the event the resistance of both are the same, this I1 will be equally shared between the 2 components. So far, does that make sense? Okay? Okay, then let me go through the next one. Now we talk about E. Okay, you look at the red color thing that I draw here. What the battery does is to raise the potential from 0 to 1.5. Okay, if there is no component along the way, you'll always be 1.5. So along this whole line on top, okay, this point on top here, okay, this point on top here and this point on top here, all this point will be 1.5 volt. Make sense? Okay, because every point in if there's no resistance there, okay, no, hold on. If there's no resistance there, it will have same potential difference. Okay, so can you see on top here? There's nothing there, only wire. Okay, so all the potential, all the value, if you were to put your voltmeter on top here, it will give you a potential of 1.5 volt. You will not be higher, you will not be lower, because nothing raised its potential and nothing let the potential drop. Okay, there's no battery there, there's no component there, you'll all be 1.5. Likewise, below, there's nothing along the bottom line. Okay, there's nothing along the bottom down here, wire. So every point on this red color block will all be 0 volt. Is that clear? So if I were to use a voltmeter to test the difference between the 2 points before and after the bulb, the difference will be 1.5 volt for the bulb. And then the difference for the resistor will also be 1.5 volt for the resistor. Clear so far? So for part E, it's trying to say that the potential difference between the branches are the same. Okay, they will have the same potential difference because nothing changed their potential. So the difference between the bulb and the resistor will be the same. So both the PD are the same in a parallel circuit. If you understand this, give me a thumbs up. Ryan and Xiaoxing, do you understand? All right, very good. Okay, so the F, G, H, I will go through later on. So now you understand the basics of series and potential. Sorry, series and parallel. Okay, then we can start to solve problem. And all the problem that you use to calculate will be using this formula. R equal to V over I. Or for me, I like to remember V equal to Ri. Some of you, V equal IR, they are all the same. Just which one is the subject. Okay, so once you know this concept about series and parallel, you just need to apply this Ohm's law, this formula into your calculation, and you can solve almost everything in your DC circuit question. Okay, so once you understand the concept of series and parallel, you just need to apply this formula, you can solve almost everything. Is that clear? Okay, so I'll just close this. The rest of the thing we'll go through a bit later on. So let's go through the notes. Let me show you the notes. How many of you actually wants the notes? Some of you ask for the notes, right? Sorry, I haven't given it to you. Those who wants the note, raise your hand. How come you want notes? Your school teacher will give you all notes, man. Okay, I don't know whether will this be useful for you. So let me just go through this. Okay, I've gone through this before. Okay, so let's look at this one again. Okay, so these are all the symbols that you all need to know. Okay, the switch, the cell, the battery. Okay, so we talk about potential meter. We haven't talked about this yet. Light dependent resistor. We also haven't talked about this yet. Yeah. Okay. When we see all these things, then we revise again. Okay. So these are the symbols that we talked about earlier on. So we talked about DC circuit. So just now I spent a lot of time talking about series. So in series, when a circuit has only one way to go, when the current has only one way to go, the current will be the same throughout. But when in the parallel circuit, the current, when it's broken up into different branches, is the same as the sum of all the other branches. Understand so far? Then for potential difference, in a series circuit, you add them up together like this. Whereas for parallel circuits, they are the same. The PD are the same. So we have gone through this earlier on. Okay, then resistance. We had not gone through the resistance. So what does this mean? I think I've gone through this in the earlier lesson. If we got two resistors, the combined resistor total is R1 plus R2. You just add them up together. Okay, the effective resistor of two resistors in series, you just sum them up. Okay, but in this example, it will be a bit challenging. To find the total resistance, you use the inverse law, the inverse formula. Okay, and then once you find that 1 over RT, you must flip it. You don't just leave it at 1 over RT. Okay, so in parallel circuit, we use this formula. Clear so far? Okay, so this is the thing about series and parallel. Then we need to apply V equal to Ri based on what we understand here. Okay, then what is a potential divider? Okay, what is a potential divider? Let me show it to you. Okay, this is a very okay, let me show you something else. Okay, what a potential divider does is this. So you look at this circuit itself. Okay, how many of you look at this, you understand? If you understand, give me a yes reaction. If you are totally confused, give me a no reaction. Okay, ignore the formula below because the formula looks very intimidating. If you understand this diagram, give me a yes reaction. If you are confused, give me a no reaction. Okay, Ryan and Pei Guan need help. Oscar need help. Auri, how about you? Okay, most of you need help. Okay, let me just draw the same circuit in a different manner. Okay, so we are talking about the series. This is a series circuit. Okay, so this is your battery source, and this is your resistance 1 and resistance 2. Correct? Okay, so if I were to talk about this is V1 and this is V2, and this is EMF, can I say that EMF is the same as V1 plus V2? Okay, basically this is the formula. Okay, so the EMF of the battery is equal to the potential difference of V1 plus plus the potential difference of V2. So if you understand this, give me a thumbs up. If you understand this, give me thumbs up. Thank you, Chelsea and Yiting. The rest will give me all the no reaction one. Do you understand this so far? It's just a revision of the series circuit. Clear? Howry and Ryan, is it okay? Okay, sometimes in a circuit, for example, your battery source is, let's say, 10 volt. Your EMF is 10 volt. But in your practical example, in your practical circuit, you do not want 10 volt of voltage. Okay, if it's 10 volt, you will actually burn or burst your circuit or your component. You need to control. You don't want such a high EMF. Okay, you don't want such a high EMF. You want a lower one. Okay, so that is where a potential divider do. For example, if you want a 5 volt EMF, okay, sorry, a 5 volt potential difference to drive your circuit, because your component cannot work under 10 volt, but you only have one 10 volt battery here. What can you do? Okay, so you use a potential divider. Okay, down here. So at this point, this blue point is 10 volt. This point here is 0 volt. If these two resistors are the same, okay, this point here will be 5 volt. If resistance 1 and resistance 2 are the same, this point here will be 5 volt. Then can we use these 2 points to power your circuit? Do you understand this now? Okay, if you understand this, give me a clap. Okay, if R1 and R2 are the same, the potential at the middle will be right in the middle, will be 5 volt. And if you just need a 5 volt PD to run your circuit, that is how you can do, even though you don't have a 5 volt battery. Okay, so what this thing do is, this component divide the potential of 10 into whatever you want. So how do you do that? You vary the value of the R1 and R2. If both R1 and R2 are the same, this value here in the middle will be right in the middle, which is 5 volt. If you want a bigger value, you reduce this, you increase this. Does it make sense? If you want a smaller value, you increase the resistance 1 and you decrease the resistance 2. Understand so far? Clear? Okay, so this is a concept where you can change your voltage to something that is smaller, which is what you want. And you don't have something of you don't have the battery source to run your circuit. So you play around with the resistor value so that you can have a voltage of what you want. Clear so far? Okay, so let me go through the first formula. This number 1. This I formula. So you know that I is V over R. Okay, this formula you are very familiar. So why we use R1 plus R2? Because R1 plus R2, you add them together. Okay, if they are in series, you add them together. Can you see this? The second formula. So R1 plus R2, because they are in series, you add them together. You know the voltage, VE. You know R1 and R2. You can calculate the I. Here, you can calculate the I. Okay, I don't like this formula. Can I propose another formula for you? Can I propose another formula for you? So V out is this, is basically R2 over R1 plus R2 times VE. Is this clearer now? To find this value V out, you just find R2 divide by the total times the V. This is how you divide the potential. Does that make sense to you now? Basically, this formula is the same as this formula. I don't know why why are they doing that? Okay, so can you see this second formula? To find the value here, for example, if this is 10 volt, okay, if the resistance here is 7 ohm and the resistance here is 3 ohm, this V out will be 7 over 7 plus 3, which is the total multiplied by 10. So can you see this divider, it divide at 7 out of 10. So it's 7 out of 10 times 10, this V out will be 7 volt. Does it make sense to you now? So this V out, this 2 will be 7 volt. Okay, ignore this formula, just use this. This is how you divide the whole thing. Okay, the total is 10. This part is just 7. So 7 over the total times the original voltage. This is how you divide the potential. Okay, if you are clear about this, give me a clap. Okay, if you're clear about this, give me a clap. If you are still confused, give me a no reaction. Okay, give me a no reaction. Okay, I'm just concerned about the first four of you, Hao Ray, Ryan, Bei Kuan, Oscar. Before this, you don't understand. But now you understand now? What is potential difference? Okay, is it clear now after my explanation? Okay, very good. So we talk about more potential divider. Okay, so can you see this is the same thing, just that this thing on top here is a variable resistor. Okay, so you look at this formula, it's the same as the one I told you just now. R2 is this one. Then the below is a combine of R1 plus R2. Okay, this VE is the total. So to find the V out, okay, you just need to plug in this formula. Does this formula make sense to you now? Does it make sense to you? Oh, okay. Okay, so this itself is better compared to this. For this, you must change the resistor to give you the V out that you want. Okay, you need to calculate. Okay, but for this example here, you just need to vary the first rheostat. Okay, the first one, you vary this one. Okay, then you can use the voltmeter to measure these 2 points. You just adjust until the point you want. Okay, you actually can give you the result. Okay, and you can still calculate the same way as the first one. The calculation is the same. Just that for this example, it is more useful because you don't need to go and change all the resistor. You just need to vary the resistance on the first one to get the whatever output you want. Okay, so this is a more useful application compared to this. This one you must calculate and then use the actual and the correct value. Okay, but for this, you adjust the first value, you can actually give you a V out of what you want. Is that clear? If you understand, give me a thumbs up. Okay, very good. Now this thing called potentiometer. Okay, this thing here, this R here, this ABC thing, this component. Okay, let me just go back a while first. Okay, let's look at this. Can you see this pattern here? This is a potentiometer. Okay, just now I talk about this rheostat. Rheostat can vary the resistance. Okay, fixed resistor like this, the resistance is fixed. It doesn't change. A rheostat, you can vary the resistance. So what does this potentiometer does? Okay, what does this potentiometer does? Let me show it to you. So for example, if I were to connect this to a battery, so if this is 10 volt on the right side, this is 0 volt on the left side. Okay. You have a third terminal here. this third terminal can move from left to right. The more left you go, it goes closer to 10. The more right you go, it goes closer to 0. So this potentiometer is like a resistor with three points. Okay, a normal resistor only got 2 points. Point on the left and point on the right. Okay, so for a potentiometer, it's the same resistor with a third point in the middle where you can move around. Is that clear? A variable resistor, the 2 point is actually fixed. There's only 2 points. You adjust the resistor value to adjust the current. Okay, but for potentiometer, it's the same resistor but with 3 points. Okay, the first 2 points is the same as a fixed resistor. The third point can vary along this value, 10 volt to 0 volt. Are you clear about this? So how do we use this in a potential divider? Okay, so this is a resistor where this point can vary along this line. Clear so far? The closer you put to B, you'll be closer to the E value. The closer you bring down to A, you'll be closer to 0. Does it make sense? Okay, let me try to understand the formula. Okay, so basically what this thing does is that this is a length. Okay, it can be like 5 cm. If you put this point right in the middle, you'll be having it'll be something like this, something like a 2 resistor right in the middle. Okay, sorry. Let me give another example. Sorry. So let me give you a potentiometer example. I have 10 resistors here. Okay, a very lousy example, but I got 10 resistors here with a battery down here. 10 volt. Okay, so my battery has a EMF of 10 volt. Clear so far? So if I were to test this point, is 10 volt. If I were to test this point, is 0 volt. Okay, it's 0 volt. Understand? So what can I do? I got 10 resistors here of the same value. If I were to connect, let me show you. If I were to continue to draw the line out here, which is this line here, if I continue to draw out the line, this line will still be 0 volt. But if I were to point, let's say I point right in the middle here. Okay, so this point now will be 5 volt. Understand? So the question about this is, this point can be moved. I can move this point. Okay, very hard to show. I can actually move this point to, let's say, to here. Okay, if I move this point to here, it will give you a 8 volt at this point. Okay, so this potentiometer is where there's a point here where you can shift up and down. Okay, the higher you shift, you'll be closer to the E value. The lower you shift, you're closer to the 0 value. So if I got 10 resistors here, what's actually happening is you're shifting this green line. The higher you shift, you'll be 10 volt. The lower you shift, you'll be 0 volt. So if I put it down here, at this point, you'll be 1 volt. If it's this point, it'll be 2 volt, 3 volt, 4 volt, and so on. So if I use this example to show you how this potentiometer works, does it make sense to you now? Okay, if it makes sense to you now, give me a yes reaction. Ryan, you okay? Hooray, Beikwan and Oscar. By this 10 resistor example to explain potentiometer, does it make sense to you? Okay, very good. Okay, so basically this AC, BC, this is length. Okay, so this is basically like a resistor wire, a very long resistor wire, it could be 1 meter or what. So when you place the pin in the middle, you want to find out what is the V out, you just measure the length. AC is this length, over the total length will give is this formula, what do you call it? This formula you can find in mathematics, right? So which topic is this? Okay, I can't remember. Okay, so this potentiometer thing, the higher you go, the greater the potential V out. The lower you go, the smaller the V out. Okay, so if I were to make it very crude, I can put 10 resistor in down here. If I want a higher voltage, I put the green point higher. If I want a lower voltage, I put the green point lower. Okay, that's all about this. Okay, but then this whole thing combined to be one thing. And this one thing is called potentiometer. Okay. All right. Let's continue. Okay, that's the last part already. Okay, so what is an input transducer? Okay, let's ignore input transducer. Okay, sorry. Input transducer is there. Okay, that's the last two part. Okay, this is the last two part they're going to learn in this topic. Let me show you some of the terms here I don't like. Okay, so remember this one. So we talk about the potential divider. Okay, so now we are going to talk about the last two things, which is what is thermistor and what is light dependent resistor. So you're using something that is not electrical to control the electricity. So what are the two things that you're going to use to control? You're going to use heat and light. Okay, you're going to use heat and light to control the resistance of the component, and that when you control the resistance, you'll control the current. Does it make sense? Okay, so the last part will be, okay, so we are going to use non-electrical energy. So this non-electrical energy got two types. Okay, just as I mentioned, there are two types. Number one is heat. Number two is light. Okay, so you use heat and light. The heat is thermistor. Thermistor is a resistor where the resistance varies with temperature. So the hotter the environment, the lower the resistance. Does it make sense? Same thing for light dependent resistor. The greater the light, the lower the resistance. Can you remember this? So for example, if you want to set up an alarm at home, okay, at night, okay, when someone on the light, then there will be alarm. So does it make sense? When there's light, there's no resistance, then current will flow through, your alarm ring. Same thing. If you want something to be, you want to have an alert when it's too hot. Okay, so when temperature goes up, your resistance goes down, then alarm will ring. Okay, so basically you're using heat and light to determine your resistance. The greater the heat and the light, the lower the resistance, current will flow through, and therefore the device will work. Is that clear? Okay. Then let me show you all the final thing before you go for a short break. How does these two components look like? Okay, so this is a thermistor. The number one, a thermistor look like this. Okay, and then the light dependent resistor look like this. Okay, so the greater the heat, the lower the resistor, then current will flow through, then the current will work. Same thing, the greater the light, the lower the resistance, then current can flow through, then the circuit will work. Is that clear? Okay, so let me just go through this diagram with all of you. Okay, switch, I don't think I need to explain. Cell, I mentioned before. Okay, DC and AC power supply, light bulb. Okay, so what is new here? What is new that we learned today will be potentiometer. It's a resistor with 3 output. Okay, So basically the first two are the same. It's just that you have one more point that can point in between the resistance to have to determine a fixed voltage. All right. Then we also learn this new thing, the light dependent resistor. The greater the light, the less resistor you have, then current can flow through. Okay, so we also talk about the fixed resistors and the variable resistor. So this fixed resistor has a resistance that will not change, whereas a variable resistor can change the resistance. So when the resistor increase, current will decrease. Okay, when the resistance decrease, current increase. Clear so far? You will learn fields in the practical electricity. You will learn coil of wire in electromagnetism. You will learn transformer in electromagnetic induction. Okay, you will learn semiconductor diode. You learned this already, right? Last topic. Okay, this one, galvanometer and ammeter, they are very similar to me. Just that ammeter give you a result, whereas galvanometer just give you an indication whether is there current or not. It doesn't give you a result. Okay, so when the needle move, means there's current. When the needle doesn't move, there's no current. So that is what a galvanometer does. It just tells you whether is there current or not. Whereas for ammeter, okay, it tells you it actually measures the current for you. So we learned this today, and we know that the resistance is close to 0. So it doesn't affect the current flowing through. We also learned the voltmeter today, and you also know that the current, the resistance is very, very high. Clear? Okay, so you'll learn this earth thing in practical electricity next topic. Capacitor, okay, the bell, something new. Okay, we also learned the thermistor today. Okay, so all the tick that I tick down here is something new. Okay, that you need to know, and you must know how to draw the diagram. Okay, so let me repeat about thermistor. The greater the temperature, the lower the resistance, then current can flow through. Higher the current can flow through, then your circuit will work. Does that make sense to you? Okay, so far up to here, how useful or have I improved on your knowledge? Okay, if you have learned a lot of things today, give me a 10. If you learn nothing today, give me a 0. Then we go for a 2-minute break. Okay, I got some question from you. I never see. So now I go and see. Ryan asked me, so EMF is just the average voltage of the circuit. Ryan, is that the correct question you're asking me? Okay, basically EMF to me, EMF is the same as PD. Just that EMF measure the battery source, whereas the PD measure the load. Okay, to me, EMF is the same as PD. Just that you use the term electromotive force to power source. Okay, it has nothing to do with average voltage. So I don't really understand your question. Okay, Ryan, can you try to rephrase your question because I don't understand your question? Okay, Yiting asked me a question. For a potentiometer, if you use the V out to power another circuit, then how the charge go through the R2 itself? Okay, wait. Hold on. Okay, let's use this example. Okay, let me just draw my own example. Okay, Yiting, you're asking me this is the EMF. Okay, so you're asking me for potentiometer, if I use V out to power another circuit, then how the charge go through the R2 itself? Okay, I think I know what Yiting is asking. Can I revise what we learned in primary school? Okay, can we revise what we learned in primary school? Okay. Can you see these two circuits? Okay, do you remember in primary school, which light bulb will be brighter? The left or the right? Can you tell me which light bulb will be brighter? The left, this light bulb A or these two light bulb? Okay, Yu Ting say left. How about the rest of you? Which one will be brighter? Left or right? Okay, Xiao Xin say left. How about the rest of you? The one bulb will be brighter. Correct. Okay, why will it be brighter? Because when you learn in secondary school, you learn in today. Okay, you learn today, the voltage of this, let's say is 2 volt. Whereas the voltage for this is just 1 volt. Okay, it's just 1 volt. So with a greater voltage, therefore it will be brighter. Okay, number 2, we don't use voltage to count. If we were to use another example. If the bulb has a resistance of they are all the same. Okay, so this one has a resistance of 1. This one has resistance. So the total resistance here is 2. Correct? Is 2 of R. The total resistance here is 1 R. So given the same V, okay, given the same V, I is equal to V equal to R, I, V equal to. Okay, so I will be equal to V over R, correct? So this total, this R total is just 1 R. On the right side, the R total is 2R. So this I is actually half of it. Okay, so therefore the current flowing through this bulb is half of the current going through this bulb, and therefore the bulb on the right would be dimmer. Is that clear? Okay, so this is the revision. I haven't got. Okay, I'm going to lead you to the Yu Ting's question. Okay, so now hold on. Okay, clear. Okay, so now I'm going to go. I'm going to lead you to the next question. This is bulb A. They are all the same bulb. We are talking about the same bulb. Now, given the same battery, okay, same battery, 5 volt, 5 volt, and the bulb are all identical. When they are in parallel like this compared to one bulb, which one will be brighter? A, B, or C? Which one will be brighter? Okay, Pei Guan, correct. Okay, which bulb will be the brightest? Ryan, incorrect. Okay, this is the primary school question. If I got we have the same bulb put in parallel, would the brightness be the same, brighter or dimmer? Only Pei Guan able to answer me. How about the rest of you? Yu Ting, incorrect. Why do you think that you put the 2 bulb in parallel, they'll be brighter than 1 bulb? How many of you are unsure? Type unsure in chat. Okay, I understand what you're trying to say, Yu Ting. Your total current is more, but the current flowing through the light bulb, you go and calculate. The current flowing through each light bulb, is it more or same? You're right, the total resistance is lesser, the total current is more, but how about the individual current going through the bulb? Got it? The rest of you, bulb A, B, C, which one will be brighter? Same bulb, same type of bulb, same battery. Which one will be brighter? The rest of you, give me some indication if you are not sure. Oscar say all the same, okay. Xiaoxing say all the same. How about the rest of you? This is the primary school question. Ryan, correct. Okay, so let me review the answer. The answer is, even though there's only one battery powering more bulbs, all 3 bulbs will have the same brightness in theory. Is that clear? Okay, why? Why? So let's give a simple calculation. If the bulb is 1 ohm, okay, each of the bulb is 1 ohm. Clear? So V is equal to Ri. So how much current flow through this bulb? Okay, the current flowing through A will be 5 ampere. Okay, V equal Ri, right? So 5 times this 5 will be equal to this 5 times 1. Is that clear? Next thing, how do you calculate how much current flowing through bulb B? Bulb B also has the same 5 volt. Do you remember? They are all sharing the same point. They are all 5 volt. Okay, so the current flowing through B is also 5 ampere. The current flowing through C is also 5 ampere. Okay, so all 3 examples, 5 ampere of current flowing through it. Therefore, the 3 of them will have the same brightness. Clear? And because there are 5 ampere going through B and 5 ampere going through C, okay, and Yiting say there is more current. This more current comes here, the I1. The I1 here will be 10 ampere. So this 10 ampere split into 2 of 5 ampere each. Okay, Yiting, did I clarify your point now? So when you talk about more current, yes, this more current is actually here, over here. Okay, but the current flow going through each bulb is still 5 ampere. Okay, so in a parallel circuit, even though you use the same battery, the brightness is still the same. So isn't it wonderful? Might as well I put everything in parallel, they'll all be the same brightness. In theory is yes, but what is the drawback? When you gain something somewhere else, you'll lose, right? So what do you lose here? So you put 1 bulb, same brightness. But your battery is the same battery, Beikwan. So the same battery, you put that 1 battery there. But the brightness will be the same for all. So isn't that magical? So might as well I put everything in parallel. I'll get the same brightness. Okay, very good. So Beikwan says that, what is the drawback? What is the bad thing? The brightness of these 2 bulbs will be the same as bulb A in theory. Okay, but what happened is, in theory, yes, the 3 bulbs will have the same brightness, but the battery will run out in the parallel circuit faster because it uses up more energy. So the battery will run out faster. Does it make sense to you? Okay. Okay, now let me go back to Yiting's question. Yiting's question is, let me read again. For potentiometer, if you use a V out to power another circuit. Okay, so he says that if I use this V out to power another circuit, maybe I use this to power my lights. Because my light bulb cannot if I put under 10 volt, you will actually burst. Okay, you actually break. I need a 5 volt to actually run my light bulb. So Yiting is asking, if I use V out to power another circuit, then how the charge will go through the R2 itself. Okay, so same thing, your current will still flow through R1. At this point here, your current will have to make a decision whether to go to R2 or go to the V out. Okay, and just like this example here, I can put 2 or more bulb in parallel. Okay, I can put 2 or 3 bulb in parallel. They'll still have the same brightness. So what happens is, if I were to have a lot, if I have a V out here, there will be still the same current going to the R2, but there'll be more current going through here. You'll be drawing more current from the battery. Okay, Yiting, do my explanation make sense? Okay, so did I answer your question? So even if your circuit is in parallel, okay, they'll still run as per normal based on V equal Ri. So you already fix your V. You already fix your V. Your component, your R is fixed. So if your V and R is fixed, the I can be calculated. Okay, so no matter how many V out you have, you will still run based on your circuit. Okay, does that make sense? I know it doesn't make sense to me. The way I say it doesn't seem to make sense. But when you fix your V and you have when you have all your component R fixed already, whatever current there is will still be drawn. Okay, so if there's more branches, there'll be just more current. Okay, so I have additional branch here, just so there'll be more current being drawn out. That's all. Does it make sense? So if there's more current being drawn out, your battery will just die faster. Understand? So in next topic, we're going to calculate the energy, okay, the power, okay, and the more, okay, let me just go through the formula with you. Power is V over I. So to calculate the power, the energy used per time, okay, you just need to multiply the V and the I. So if there is a VI here, the V in this case is 5 volt, the I is 5 ampere. The power to run this bulb, okay, the power to run this bulb, okay, the power to run this bulb will be 5 times 5 will be 25 watt. So it means that every second you use up 25 joule of energy. Same thing, the power to run this bulb will be also 25 watt. Okay, the total power to run the circuit on the right side will be 50 watt. Is that clear? The total power to run the circuit on the left side will be 25 watt. So does that make sense now? So even though it's fixed at 5 volt, but the parallel circuit will draw more power. Draw more power means you use up more energy per second. Does it make sense? Okay, so you'll still run, you'll be brighter. No, not brighter, you'll run as equally bright. You can put 2, 3, 4, or 5 bulb in parallel. They'll all be equally bright in theory. Okay, why I here emphasize in theory? Because if you go to your lab, you go and ask teacher for bulb and wire. The more parallel you put, it become dimmer and dimmer. Okay, that is what happens in practical. Okay, but in theory, they're supposed to be the same brightness. Okay, is that clear? Okay, in theory, they're supposed to be the same brightness. And it's just that what happens is you just draw more power. So 50 watt, if you remember what does watt means, it means that it draws 50 joule of energy every second. Clear? Okay, so if you put more in parallel, you will just use more energy every second. So if you have this V out here, you'll still work. There'll be still current going through R2, there'll be still current going to the V out. But the overall power, overall energy used every second will be increased. Is that okay? Okay, very good. Now let me go back to Ryan's question. Ryan's question, I don't understand. Ryan, can you repeat your question? You're saying what? EMF is just the average voltage of the circuit. Can you rephrase your question? Because I don't understand your question. Ryan, don't shy. Okay, so did I actually clarify a lot of concept today that you missed out in school? Okay, I'm talking about concept, the idea. I haven't even gone into calculating. Because once you know the concept, the calculation will make sense naturally by itself. Everyone okay? Okay, let me just go back to one more example. Since the time is actually quite short, I will not go through one sample question. Let me just go back to the same example again. The 1 bar and the 2 bar. Okay, I use the same example. Okay, this is 5 volt. This is 5 volt. If the battery, if the light bulb, they are all of the same resistance. This is 1 ampere. Sorry, this is 1 ohm, this is 1 ohm, this is 1 ohm. Okay, I know that in real life it will not be 1 ohm, but just for easy calculation, the resistance of the bulb is 1 ohm. Okay, so what is the voltage of the bulb here? The voltage of this bulb will be 2.5 volt and 2.5 volt. Does it make sense to all of you? So now I want you all to calculate what is the current flowing through all this. Okay, can you all calculate the current? So you just need to use the V equal to RI formula. So the first one on the left is very simple. Your V is 5, your R is 1, your current will be 5 ampere. Okay, so 5 ampere of current flowing through this will give you 5 ampere of brightness. Does that make sense to you all? Okay, so if I look at this first bulb by itself, okay, V is equal to RI. The V is 2.5. The R is 1. So the current flowing through this is just 2.5 ampere. Does it make sense? Because this is a series circuit, the current there's only one way to go. So it's only 2.5 ampere of current going through the whole circuit. So from this calculation, which you did not know in primary school, based on this calculation, are you convinced that these two bulbs is actually half as bright compared to this bulb? Does that make sense to all of you now? Okay? Does it make sense? Because it's 2.5 ampere, it will be less bright. And earlier on, I used the same example of the two bulbs in parallel. Okay, the same 5 volt battery, the same 1 ohm bulb, and both bulbs now has a PD of 5 volt. So the current flowing through each of them is now 5 ampere and 5 ampere. Okay, so these two bulbs will be the same brightness compared to this because they all have 5 ampere going through it. Clear so far? And because it's parallel, the combined current will be 10 ampere. Clear? Did I sum up the whole thing today? Quite okay. Okay. One more thing that Yuting actually used to calculate just now. Okay, so let me. Okay, so we see this example here. Let me illustrate now. Resistance 1 is 1 ampere. Resistance 1 is 1 ampere. So this whole circuit can be redrawn into one resistor. So this is your resistor total. Correct or not? So if I use the 1 over RT equal to 1 over R1 plus 1 over R2, okay, you end up this RT will be 0.5 ohm. That is what Yuting calculated just now. So are all of you convinced? If R1 is 1, R2 is 1, 1 plus 1 is 2. So 1 over RT is 2, so RT will be half. Clear? Then the voltage is still 5 volt. So 5 volt, okay, the V is 5, the R is 0.5 ohm. Are you able to all calculate? The current will be 10A. Is it magical? This 10A is the same as this 10A. They are the same. Clear? Okay, so if you were to combine the two bulbs to just do simple calculation, this combination of the two bulbs will give you the total resistance of 0.5 ampere. Clear so far? And this 0.5 ampere, sorry, not 0.5 ohm, okay, 0.5 ohm with 5 volt will give you a 10 ampere of current. So this 10 ampere is the same as this 10 ampere here. Okay, so do you see everything actually times up very neatly? Okay, same thing for series. Okay, I use this example. This example, if I were to draw a similar diagram, same thing, it will be 5 volt. This RT will be now 1 ohm plus 1 ohm. It will give you 2 ohm. Correct? So the current in this case will be 2.5 ampere because V is equal to R times I. So 2.5 times 2 give you V. So can you see this 2.5 is the same as this 2.5? So if you understand the whole thing, they are actually all points to the same thing. Okay. So did I tie in everything together for you? Instead of separate them, now I tie up to you. Was it helpful? If it's very helpful, give me a clap. Aure and Beikwan, are you okay? Thank you, thank you. So hopefully I have managed to make you all understand the whole concept better. Because once you understand, there's very little thing to memorize. Do you agree? Okay, once you understand, it's just like cycling. You just remember for life. But if you don't understand, just memorize and just force yourself to memorize, you can still solve exam question about next year you forget again. Okay, so that's not what I want to see from you. Okay, so once you understand this basic concept, it shouldn't be hard to forget. Clear? Ken, I got no question for you today. I only have one question for you. Okay, I got no physics question for you because the formulas are all the same. So the only thing, okay, wait, let me just go through one last thing. One last thing, just to consolidate the idea. Okay, potential difference. Let's say I got two resistor. Okay, this is, let's say 1 ohm. This is 4 ohm. And if the same thing, I give you a 5-volt battery. Okay, a 5-volt battery. Okay, so how do we calculate this? Okay, we know that the total is 5 ohm, correct? Okay, so the V across the first one will be 1/5. Will be 1/5 multiply of this 5 volt. So give you 1 volt. Same thing. This is 4 out of the total of 5. So this will be 4/5 multiplied by 5 volt will give you 4 volt. Does it make sense to you all now? Okay, so this is how a potential divider works. You know how it's divided is linearly related depending on the resistance of the two parts. Is that clear? So is this calculation make sense to you now? How a potential divider works? So you can divide using fixed resistor. You can divide using variable resistor. Basically, it just vary. It's like playing with the ratio. And then you can get the answer. Okay, got it? Okay, so before I let you go, tell me one thing you learned today. Once I call your name, you may leave. Thank you so much. Okay, tell me one thing you learned today. Once I call your name, you may go. So this potential divider thing, you understand, huh? Clear, huh? Okay, thank you, Ryan. Oscar, your statement is not wrong, but that's not the right way to explain. Okay, but you may go. Okay, thank you, Howry. Thank you, Eating. Wei Kwan, tell me one thing you learned today. Xiaoxing, your this formula, try not to memorize, but you understand the max behind it, it should be okay. Are you memorizing this formula or are you going to, or you understand the max behind it? It's just like comparing ratio. Okay, thank you, Pei Kwan. Okay, thank you, Xiaoxing. Good night, everyone. Take care. See you all next week. Bye-bye. Good night.